So, Dana, we're back from lunch break, Mahlzeit. Wie war's Essen? Everything good? Very good. I heard we didn't run out of coffee, but out of coffee cups, but I think there were more coffee cups coming in. Everything good with the coffee? Maybe, yeah, awesome. So, as always, we still have a minute or two to go. Next session, as you can see here, making your Kubernetes-based log collection reliable and durable with Vector. And I want to just quickly look at my schedule of the conference because, as I mentioned, and I know this is a repetition for some of you, but after this one, we have a slight change, the session from 2:15, and now we've also updated the website. So if you look at the website after this talk at 2:15, we have Solving Kubernetes Mysteries with Kate's GPT, your AI-powered troubleshooting companion. That's happening after the session from Maksim, and then we have one more. It's called the Kubernetes Operator Story from Idea to Cloud Integration, and then we have the surprise event at 4 o'clock, which is then also kind of the closing for today. But for now, I think, as you said, Maksim just said the bad thing about the cinema here is that the chairs are too comfortable. Right? It's probably it's easy to fall asleep, especially after lunch, but I'm pretty sure nobody will fall asleep because you have an awesome presentation prepared. Maksim, a couple of words about you. You're living in Ulm in Germany. Yep. You're the platform lead of all platforms that are built within Palak. Yep. Yeah. Philip, can you make sure that his mic is also on? Perfect. Thank you. Try it.
Yes.
Yes, awesome. You are a contributor to Kubernetes.
Yep.
Yeah. Just give us a little bit of insights. Contributing to Kubernetes can be a little scary for some, but
mostly to SIG authentication. So in upcoming releases, there will be the cap about authentication configuration. So you can define authentication for Kubernetes in a structured way in a single config file. So I participated in writing this cap.
Very cool. So folks, if you ever want to talk with somebody that actually contributed to core Kubernetes, Maksim is the person to talk to. You're also the maintainer of DEX, the IDP.
Yep.
And now to your session, I think we will hear a lot about how important it is that you have reliable logs. We hear about Vector, and what we also hear is not just the good stories, but we hear the stories, what happens if things fail, and how do you react. Some stories that I think will be very relatable to many people because not everything is perfect all the time.
Yeah, you are absolutely right.
Yeah.
Yep.
What's perfect today is the HDMI connection and the audio and your presentation. So a big hand of applause for Maksim.
Yeah, thank you. So hello everyone, my name is Maksim Nabokikh, but in this region people tend to pronounce my surname as Nabokikh. So today we will kick out the topic about how you can make your log Kubernetes-based collection reliable and durable with Vector. So, and before the talk, I want to assure you that during this talk preparation, no Kubernetes clusters were hard. And of course, it's a joke. I'm joking. There were plenty of outages in the real. Okay, who we are? So we are Pelark, and we are a service company. So we are building internal Kubernetes platforms for our client using the best open source solutions on the market. And we also support these platforms 24/7 with our own engineering teams. So on the slide, you can see some numbers. And for us, log collecting feature is important because applications, they may expose no metrics, don't be adapted for traces, but logs, they are always there. And sometimes it's the only signal we can use for monitoring. Okay, so the plan for today's talk. At first, we will just recall what to collect in Kubernetes, which logs we can collect. So in the second part, I will tell you about Vector, how it's applicable, why we love it. And in the third part, the most interesting one, I will tell you about some practical use cases, some exciting stories from our operating experience with Vector. So, logs in Kubernetes. The main goal, sometimes we forget about this, but the main goal of Kubernetes is to run containers on nodes. And application in these containers, they're usually written according to 12 factors of Heroku. So they're writing their logs to std out or stderr. And then container runtime can collect these logs and store these logs in a folder. Usually it's varlog pods folder, but it is configurable. It can be anything. What else we can collect is, like there are some services on nodes that are not in containers. For example, containerd, kubelet. So they are not in containers. We may also want to collect some messages from syslog, for example, like SSH authentication messages. And there are some edge cases, for example, containers that write their logs on the file path, for example, Kube API server. So Kube API server usually writes audit logs on the file path, so we also need to collect these logs from a node. And the third thing we can collect in Kubernetes is events. So events a little bit special because they only exist in etcd, and you need to request your Kubernetes API to collect events. And events, like this is a special structure because it can be collected as metric, because events has the reason field that shows, like that it identifies this event, and the count field that is actually a value because event is a counter, so when more events occur, so the counter increases. Yeah, so it can be collected as trace because there is a first timestamp and last timestamp fields, so you can draw a beautiful Gantt diagram of all events of your cluster. And finally, there is a human readable message, so events can be collected also as logs. Okay, so we can collect pod logs, node services logs, events, and in today's talk we will only cover these two things because events, they are, special. You need additional software to scrape events from Kubernetes API, so we will not be able to cover this today. Okay, what is vector? There is a statement from the vector website. I adjusted it a little bit to highlight what we, as a company, value the most in vector. So for us, it's important that vector is open source tool because otherwise we wouldn't be able to suggest it for our clients. For us, it's also important that vector is efficient tool. So if a tool is lightweight but cannot handles a lot, so we cannot use this tool. Or if the tool is ultra fast but consumes a lot of resources, we also cannot use such log collector. So we need it to be efficient. And for us, it's not important that vector can collect other data. We are only into logs today. What else is great about vector? So vector is vendor agnostic. Despite being owned by Datadog, vector has integrations with Splunk, with Grafana Cloud, with Elasticsearch Cloud, so you can use a single software for all the vendors. And another great thing about vector is that to make your Go application more performant, you need to rewrite it from Go to Rust. Everyone knows this. But vector is one step ahead. It's already written in Rust, so you don't need to rewrite it. And vector is also performant by design because if you want to open a pull request to vector, there is a CI system, and CI system will run some benchmarking test, and maintainers will see that whether your feature affects vector performance badly, and if so, they will ask you to fix this. Yeah, because the performance is their key feature. And vector is also a flexible building block. We will discuss it in following slides. So vector architecture, vector's architecture. So the architecture is simple. This is data processing tool, so it needs to collect data somehow. So vector can either scrape data from some sources or pretend to be, for example, an HTTP server and accept when other tools will try to ingest some data into vector. So then vector can transform log entries. It can change log entries, drop some entries, or aggregate like many messages into one. And then vector can process messages forward to storage or a queue system, so whatever. And I want to say that don't be fooled by the number of transforms here, because vector, it has, so they developed their own transformation language called vector remap language. So the actual number of transforms here, so it's the infinite number. Some examples of how we can use vector remap language. Yeah, let's go. So the first one is how we can filter logs. So the condition there in the example is the vector remap language expression. So basically it takes the severity field and just checks to, like it to be not equal to info. So the second example is a little bit more complicated. This is a real world example. So when vector collects logs of pods, it enriches also these log lines with metadata about the pod, like pod name, pod IP, pod labels. And in pod labels, sometimes there are labels that only used by Kubernetes controllers. So they are not informative for humans. We don't need them. They can affect performance of the storage badly. So the best choice is to drop these labels. And this is an example how you can concatenate log lines into a single one. So the important fields here like merge strategy. So merge strategy says that we will concatenate message field with a new line symbol. And the ends when section, like this is a viral expression, and it just uses regular expression to check whether the line ends with the backslash. So it's like a concatenation of multi-line bash commands. Okay, so vector can be used in many log collecting topologies. So the first one is distributed topology. So there are vector agents on all Kubernetes cluster nodes. And they are collecting logs, transforming logs, and sending logs directly to storage. Pretty straightforward. So the second one is centralized topology, and this topology is a little bit more complicated because there are still vector agents on all nodes, but they do not do complicated transformations. So all the complicated transformations now are in aggregators. And the good thing about this is that the load is more predictable. So we can deploy aggregators to dedicated nodes. We can scale them if we want. So we can just reduce the load that vector, like resources consumption of vector on the nodes of the cluster. And the third one is stream-based topology. So by using this topology, we are trying to get rid of logs as fast as possible, because when we are ingesting logs into storage directly, Elasticsearch tries to parse log lines, try to adjust some indexes. Yeah, but Kafka can handle all the messages. For Kafka, it's just like a string, so we can send everything to it and then asynchronously take messages out of Kafka and put them into our storage to see these logs. Yeah, and there are three topologies. We will today only cover this part because, so we will not be able to cover the part where vector can act as aggregator. So only the vector as nodes collecting, node logs collecting agent. Okay, so how vector looks in Kubernetes. This is like a schema of our pod. It's so the setup is a little bit sophisticated. But I will try to explain you why we need such a setup. So the first container of our pod is vector. So we discussed it. So we needed to collect logs. This is the main container. The second one is reloader. And because we are building a platform, we let our users to write their own log collect and log ingesting pipelines. And we have some special operator that takes these rules from users and composes a configuration map for vector. So reloader, it is in charge of validating this config map and reloading the vector, of course. And the third container is Kubernetes proxy, because vector exposes a lot of metrics about which log lines it collects. So we need the information can be a little can be sensitive. So we need to protect it with authorization, and we can do this with Kubernetes proxy. Okay, vector is a diamond set because, as we discussed previously, we need to deploy agents on all nodes of the cluster. And to be able to collect logs, we need to mount some additional directories to vector. For example, var log directory, because all logs probably stored there. Pod logs, not services logs, so all logs is in this directory. We also need to mount some persistent volume for vector, so we can mount a host path. So vector need a persistent storage to store checkpoints, because when vector send a log line, it writes a checkpoint that vector did this to avoid sending log twice to the same storage. Yeah, and we also mount local time zone because our users ask always about the local time zone, so we need to to know the zone of the node. Okay, and important thing that when you're mounting var log directory, you don't need to forget. You need to not forget to toggle the read-only toggler because it's important. Otherwise, people will be able to alter log files from the pod of the vector. This is not what we want. So we also used the termination grace period second to be sure that vector finishes all his tasks before restarting. And the last one, share process namespace, because otherwise the reloader will not be able to send vector a signal to reload it. Yeah, this is our vector setup. Okay, and then the final, the most interesting part about our practical use cases. And these use cases, this is not actually use cases, they are real world outages we face during our duty shifts. The first one is no space left on the device. So one day all pods were evicted from a node because of a disk pressure. We started investigation and found out that vector actually holds deleted files. So this is vector. It holds these many deleted files of pod logs. So why it happened? So vector watches files in the varlog pods directory, and if your application write logs intensively, so the file can be like of a size of 10 megabytes, then 20 megabytes, then 50 megabytes, and finally Kubernetes comes and rotates this log file, and now it's again the 10 megabyte sized. Okay, but at the same time, vector tries to send logs to Loki. And Loki says like, no, please stop, I cannot handle such many logs. But vector is honorable software. So it still wants to send all the logs to the storage, but applications, they don't want to wait. So vector tries to hold all the logs files, and Kubernetes comes and rotates them until the space ends on the node. How to fix this? So by default, firstly, you may want to adjust buffer settings, because by default, a vector stores all the logs in memory, log entries, if it cannot send it to the storage. And the capacity of the buffer by default is just 1,000 messages, so it's pretty low. You may want to increase it to 10,000. You may want also to change from blocking behavior to drop newest behavior. So when there is drop newest behavior, vector will just drop all the logs it cannot put into its buffer. Or like the other option is just not to use in-memory buffer and use disk buffer. It works well, but vector will spend more time doing input-output operations. Yeah, so like a trade-off. Actually, to fix this problem, the rule of thumb is just to use stream topology. So we just need to let logs go out of the node as much as possible not to affect our production applications, because we don't want to ruin production cluster because of the monitoring. Yeah, and if you're brave enough, you can just use sysctl to adjust the maximum open files for a process, but I actually don't recommend to do this. Next case, Prometheus exploded. Why so? So vector works on a node, It collects logs of pods, and it also exposes metrics about how many log lines it collects, how many errors were. Yeah, so because Vector has a great observability feature. But for each, like for many metrics, there is a special file label. And this file label is a potential cardinality bomb for Prometheus. Because when pods restart, Vector start exposing metrics for new pods, uh, but still exposes the metrics for old ones, because this is just how Prometheus exporter works by design. So, and a couple of more restart and Prometheus explodes. We immediately applied the metrics relabeling rule to just eliminate the file label. Yeah, and waited for the best, and with Prometheus everything was okay. But after some time, Vector exploded. Because vectors still need memory to store all these metrics, and it's just because of the memory leak. Yeah. How can you solve this problem? So there is a global option in Vector called expire metric seconds. So you can set it, for example, to 60, and Vector will check whether there are still data that it collects from these pods, and if not, so it will just stop exploding metrics for such files. It works well, but breaks some other metrics. For example, metrics for vector component errors. Because as you can see on the graph, so 7 errors occurred, and then expiration was triggered. And after that, there is an empty space. And Prometheus, so like rate function or increase functions, so in Prometheus, they cannot handle this empty space. So Prometheus expects you to expose the metric for the whole period of time. So it's not possible to use rate in such case. What we did exactly is we just patched Vector to eliminate the file label completely from the code. And it was okay. So this is not the full patch, but just like a piece of it for you to get the idea of what we did. Yeah, so that's it. And the final case is Kubernetes control plane outage. Whoa. So we noticed one day that when like vectors restart at the same time, Kubernetes control plane dies. So we checked our like dashboards, and we saw that this was because of the memory consumption, mostly because of etcd memory consumption. And why it happens? So to understand this problem, we need to deep dive into Kubernetes API internals, and what is the case? So Vector, when it starts, it makes a list request to Kubernetes API to fill the cache with pods metadata, because Vector, as we discussed previously, needs this metadata. So it needs this metadata to enrich log entries with it. So, and each vector asks Kubernetes API to give only metadata of pods on the same node as vector is where vector is running. But for each request, Kubernetes API goes to etcd, but etcd is pretty dumb in terms of like storing the data. So in etcd, etcd is just a key value database, and keys are composed from the kind of resource, namespace of resource, and name on resource. So for each request of 110 pods on a node, Kubernetes API goes to etcd and requests all pods from etcd. And that's why memory consumption of both kubeip server and etcd grows, and they both die. How to solve this case? It is possible, so the first thing, like a cache read. We can say to API server that you don't need to go to etcd, just give me what you have in your cache. It may be inconsistent in some points because of like when you have more than one API server, but for monitoring tools, it's okay. But unfortunately, there was no such feature in Kubernetes Rust client. So we added a pull request and pull request to vector. So now you can use the option called use API server cache true. So this is the option. The second thing how we can fix this is a special feature of Kubernetes priority and fairness API. So on the left, you can see like we can define the queue for requests, and to the right, you can see that we can attach this queue to some like service accounts. And with this, we can limit the number of pre-flight concurrent requests. So this is the graph before, and this is after. So there are still spikes, but not that severe. So the impact is not that severe. Yeah, and you can also use Kubelet API to get post metadata instead of Kubernetes API. This is not implemented in Vector. This is idea for you if you want to contribute. So you can go and implement this feature, but you need to write the code in Rust. Yeah, so that's it. Conclusion. The first thing is that Vector is great for platform engineering, to build platforms. So because it's flexible, because it has the variety of ways to ingest logs or to transfer logs. Yeah, so this is pretty flexible. So the second thing is that Vector is just awesome. Seriously, deploy it today. You can use Helm chart. You can use other options. Go today. And the third thing is that I hope that we will share practical cases with each other and learn together, because I really hope that my today's talk will save someone hours of debugging. That's it. Thank you so much.
And perfectly on time. Thank you so much. We have our mic runner again, Andreas. Yeah, he keeps running and running like the Duracell bunny. One thing that I liked about your use cases is it reminded me of talks that I did years ago about the top performance problem patterns that I found in distributed systems when analyzing distributed traces. The last example with the uncached data, like requesting too much data and then filtering in a component, was one of the patterns that I found in distributed systems. So it's interesting to see that it's the same pattern happens here as well.
I think that this is the problem for also, for example, CNI drivers like Cilium, when each pod requests a lot of resources from Kube API. So yeah, so it can be faced in many different places, interacting with Kubernetes.
So folks, who has a question? Raise your hand. Robert here on the 5th row.
So this might actually be hard to answer, but in your opinion, why is Vector better than the other tools that are out there, like Promtail or FluentBit?
So the second one was FluentBit, and the first one, Promtail. Actually, I think so I like to answer this question that we all love something we used to use. So for our use case, we search for some software that is performant and that we can contribute to, because like from my experience, every software has bugs, and if you can fix these bugs yourself, so this is great. And we weren't experienced engineers like with Rust, but for us the code of Vector seemed to be okay. So we decided to stick to this software, and now for us this is just the best choice.
Who else has a question? All the way in the back.
Hello, thanks for a great talk. You said that initially on the first slides, you said that you use push data from Vector to Elasticsearch, and on the next slide you showed that you send data to Grafana Loki. And the question is, which system for log storage you use?
So
and
because
why?
Thank you for the question. Because we are working with many different clients, usually clients they already have some storage in their company, like the generic storage for all the logs. And for us, it's important that Vector has many integrations with different storages, because it's like a socket, and we can like plug any system to the Vector. And this is why we value vector also the most, because like there are many integrations we can use in our clients, for our clients.
I think this is also kind of the beauty and the challenge with Kubernetes and the open source space, because we have so many different tools to choose from to get the same use case achieved. And I think, as you said it, pick something that where you feel comfortable with. I think in general, if you have 5 options, there's some good best practices. Look at how active the community is. Look at who are the adopters. Look at how many people talk about it. That's always a good indication on whether this is a viable product or a project. But in your case, as you said, it looked good for you, and it has proven to be a good choice in your organization. There's another question back there.
Hello, thank you for your talk. How many concurrent outputs I can use in Vector? Is it just one or many?
Throughput?
How many outputs? How many concurrent outputs? So if Vector is collecting, to how many different output streams can you send data to?
I will use the slide. So there is the slide with the piece of configuration. Let's just go all the way back here. So there you can see inputs, inputs field. And inputs is the way of building pipelines in vector configuration. So you can define as many inputs as you want. Then in the second thing, so the second thing for this will be like a sink where you are storing the data, and in this thing there is also input field, and you may specify as many transforms as you want, and this is like a tree. You are building a tree of inputs and outputs, not a tree, like a graph, even a graph. So there can be different options, like many outputs, many inputs, and to handle such complicated schemes, Vector has special tools for debugging. So you can use a special vector graph command. You can, like, this is a command line thing. It will give you a graph with format of all your log collecting pipelines. So you will be able to see this on the screen. This is convenient sometimes for debugging.
So the answer would be, if I understood it correctly, if Vector is collecting data from your logs, it can send it to more than one output.
Yeah, and it can also collect from more than one input and send to the like many storages. This is.
This is raising your hand, or you're yawning, or you stretch? Oh yeah, he's raising his hand. Last one.
Hi. You obviously mentioned in this talk using it for logs. It does metrics as well. Have you had success using it for metrics as well? And given that it doesn't do traces, are you using something else as well, like the hotel collector or something in a similar fashion for traces? Or are you just focusing on logs as a company?
So the traces feature, like traces in Vector, as far as I'm concerned, so this feature is still under construction. Yeah, but they can collect metrics and send metrics, but we don't use Vector for this because Prometheus actually works well for our use cases. So we just use Prometheus for this, like to scrape and remote write metrics somewhere. But actually, many our clients ask for the feature when they want to make metrics from logs. For example, there is a Postgres database, you want to scrape logs of it and like show some counters of the particular event. Yeah, this is a great use case, and we in our blog, in Pelarg blog, we have article about this. So if you want, I can send you a link. So this, yeah, there is a successful use case of ours.
All right, and with this, I want to close this session. Again, a round of applause for Maksim.
Yeah, thank you so much.
We have a 15-minute break as always, and then, as I said, the 2:15 session has been changed, and it's now going to be a session around Kate's GPT, because the session that was originally scheduled, unfortunately the speaker had to cancel. So if you want to get the details, you can also go to the website. But yeah, we'll be back here in a couple of minutes with the next session. Bye-bye.